Now sulfur exhibit as S8. It is its molecule. It can also exhibit in different allotropic form. What are allotropic forms? In which element has same chemical properties but different physical properties. Same chemical but different physical property. That is called allotropy. You have already seen this allotropy in case of carbon, in which it was exhibiting as graphite and diamond. So these are two allotropic form of carbon. Okay. Now सल्फर की जो फॉर्म्स हमें या जो कंपाउंड्स है हमारे पास मेजरली डिस्कशन के लिए, वो एक है सल्फर डाइऑक्साइड. Sulfur dioxide, although it's a pollutant, atmospheric pollutant, atmospheric pollutant, and at the same time, it is important reagent, a, a very strong and famous reducing agent, right? Strong reducing agent, famous as well. Now, sulfur dioxide at the same time acidic in nature as well. So first of all, you need to know how to prepare it. It can be prepared by direct oxidation or roasting of sulfur, right? Sulfur plus oxygen gives sulfur dioxide, or even you can prepare it by oxidizing iron sulfide. It makes Fe2O3 and sulfur dioxide. So sulfur dioxide is important in the like in industry. Sulfur dioxide has a major use of preservative, especially for beverages like alcohol, wine, and sometimes canned material or canned food. But not in all cases. Like you cannot use sulfur dioxide in all type of canned food. But up to certain extent, you can use it. But the major thing in which it deals with, like preservation of wine, it prevents oxidation of wine. Prevent oxidation of wine. ठीक है. It can also be used for bleaching wood pulp. It is also used for bleaching wood pulp. ठीक है, used in paper making. right? The second compound of sulfur is sulfuric acid. Sulfuric acid, it can be prepared by, like, industrial method is called contact process. What is it? Contact process. In contact process, we have few steps to remember. We are only dealing with the reactions that are happening in contact process. So there are certain reactions. First of all, purification of air. Step number one, purification of air. Air, particularly, we are talking about oxygen, which will be used as a raw material. By the way, raw material are sulfur. Number two, air, and number three, sulfuric acid. So this would be surprising. For making sulfuric acid, we are needing sulfuric acid. Why is that so? You will get to know. So step number one is purification. Step number two, drying and whatever, dehydrating air to prevent other reactions. But actually, we are moving towards the reaction involved. The first step is making of sulfur dioxide, which is you already have seen in the previous case while making sulfur dioxide industrially for other purpose. Now, sulfur dioxide is made in step number two after purification of air. This is exothermic reaction, right? Although its combustion, as you have seen in enthalpy, if something is reacting with oxygen, that is combustion reaction. So combustion of sulfur must be exothermic. Step number three is the most vital and important as far as your papers are concerned, because this reaction is involving a reversible phase. Now, this is a gas, this is a gas, and this is gas too. Usually, reversibility occurs. If you will find it, you will someday realize that most of the reactions that are showing reversibility have same type of phases or same types of states. Either all of them are gases or liquid with aqueous. So there should be same phase involved. There are very few exceptions in which you will not find same states. But in most of the reaction that you will study in your syllabus involve reversibility among same phases or same states. So this step has some special requirements. The temperature will be 450 to 550, which is again compromising temperature, and pressure 1 atmosphere to 2 atmosphere, which is not very much. Like usually we have 1 atmosphere pressure on our cell, right? जो हमारे पास जो रूम टेम्परेचर प्रेशर वाली बात है वो 1 एटमॉस्फेयर तो होता ही. So just to increase the rate a little, we can have a, like flexibility from 1 to 2 atmosphere pressure we can use in industry. Now, if you remember, in Haber's process, we were needing pressure about maximum 200 atmosphere, and this time 100 times less pressure is needed. ये बहुत कम हो गया. 100 टाइम लेस तो बहुत कम होता है. अच्छा, दिस इज द प्रेशर. अब सोचने की बात है कि अमोनिया इज नीडिंग दिस मच, whereas sulfur trioxide is needing very. So whenever you have larger molecular size, you need less pressure, right? And we have less difference in moles from reactant to product. There is just difference of 1 mole from reactant to product. But in Haber process, we have hydrogen gas along with the difference of 4 is to 2, 4 mole reactant, 2 mole product. So we can apply pressure to keep the reaction in forward direction. You remember we have seen in case of Le Chatelier that we can operate through pressure as well. We can give, like, we can move the reaction according to our need by operating with the condition of pressure. Okay. Step number 4, dissolving. One more thing. You need a catalyst, vanadium 5 oxide in this case. What's the catalyst? Vanadium 5 oxide. Formula V2O5. Okay. So this is the catalyst which is needed, and catalysts are usually needed to raise the rate of reaction. Catalysts never decide the dimension of reaction in case of reversible. So whatever sulfur trioxide yielded in this process, this is dissolved in sulfuric acid. This is dissolved in sulfuric acid, and it makes pyrosulfuric acid. This is pyrosulfuric acid. You can call that oleum as well. Oleum, I'm calling this oleum because it has oil like appearance, but chemically we can call it pyrosulfuric acid. Now, this pyrosulfuric acid is added or showered with water. It makes H2SO4. So, the mole of sulfuric acid that you have used, and 1 new mole of sulfuric acid is produced. So, the acid that you have used is reproduced. Okay? And 1 extra mole of sulfuric acid is produced along with it. Okay. So why we call this a contact process? Because all the reactions are happening except for this, the last reaction, step number 5. This is happening in a separate chamber, while rest, like first 3 reactions are happening in the same chamber, and all of the reactants are in contact with each other. So which is why we can call it contact process, but there's no other reason to call it contact process. Okay. Now, second, sulfuric acid, something that is made in this process, is very important reagent. This has different uses. First of all, this is an acid, or you can call it dibasic acid. What type of acid? Dibasic acid. This is a dehydrating agent as well. Agent. This is something that removes water. You remember the case of ethanol to convert this into ethene and water. So this helps in making alkenes from alcohol by dehydrating agent. And what other use that you need to know? It is a catalyst for number of reaction, like for example ester making, etc. Sulfuric acid has different uses. Okay. Now something which is new for you is dibasic acid. Sulfuric acid can liberate one H plus ion, or it can liberate two H plus ion. So that's why we are calling it dibasic acid. A dibasic acid is something which can produce two different types of salts with metal. Different types of salts, which is why we are calling it dibasic acid. Now, we already have discussed the conditions. How to operate a reversible reaction to get or to obtain maximum yield. It doesn't mean that this maximum yield is 100%. No, it's not like that. It may be maximum around 30-40%, right? And we cannot get more than that, industrially talking. So let me repeat that. Lee Chatelier was the person who stated that if if a condition is altered for a system that already reached to equilibrium, that already has reached to equilibrium, so any change or any alteration, comma कहते हैं यहाँ पे, any change will be counteracted by the system. ये बात हम ऑलरेडी प्रीवियस वीडियो लेसन के अंदर भी देख चुके हैं. And according to Lee Chatelier, we can operate with three different things. Factor temperature. इसके लिए फैक्टर जो याद रखना है, इंक्रीज इन temperature favors endothermic side of the reaction. Second factor, pressure. Increase in pressure favors the side with less number of gaseous moles. See? And the third factor that he explained increase in reactant concentration and removal of product keeps the reaction in forward direction. All right, so these are three conditions which can be altered to keep the reaction in forward direction to get maximum yield of the product. So there is one thing which is associated with dynamic equilibrium. What is dynamic equilibrium? A point when rate of forward reaction becomes equal to rate of backward reaction. ठीक है? So if I make a mathematical statement for this, first of all, rate of forward reaction, if this is a reaction A plus B reversibly giving C, the rate of forward reaction is directly proportional to the reactant of forward reaction, the concentration of reactant of. So more the concentration, more the rate. So I can abbreviate it by calling it rate of forward reaction A, and whenever I have to remove sign of proportionality, I have to apply a constant. So this will be my first equation, right? Similarly, rate of backward reaction. This is directly proportional to the reactant of backward reaction, which is C. So once I remove the proportionality, first let me abbreviate it C, and R rate of backward B, K. So if I take this statement, a point when the rate of forward reaction becomes equal to, so I can call it RF is equal to RB. This is the dynamic equilibrium, right? And if I substitute the value of both, I can call this is the constant for forward, this is the constant for backward. So rate of forward reaction is equal to this Kf A B and Kb C. So rate of forward becomes equal to rate of backward. So let me collect both the constant on one place. So my new equation will become Kf over Kb, concentration of C over concentration of A and B. This these both of these constants are associated with the concentration of reactant and product. So this ratio will be written as Kc C over concentration of A and concentration of B. So this is the constant reversibility constant for concentration, right? You can simply write this Kc is equal to concentration of products over concentration of reactant. Now, so you will find number of expressions for this Kc thing, right? For example, if you have a reaction CO plus 2H2 reversible giving CH3OH, right? Remember that reversibilities usually happen when we have same states. So for this, the Kc expression for this will be concentration of product over concentration of reactants. Now, remember one thing, you cannot ignore these balancing integers. So whatever the coefficients are for the equation, they will be used as power in the expression. Okay, so the Kc has no specific unit. That depends over what type of equation that you are developing. Now, if I'm calling that this square bracket is representing concentration, the unit for concentration will be, in for this case the units will be there is methanol whose unit should be mole per dm cube. This should be mole per dm cube as well. Let me bracket it. And hydrogen twice, mole per dm cube square. So this cancels this. The overall unit becomes 1 over mole square dm6. We can have variety of units for the same question, for the same quantity. Okay, now let me give one example on generalized basis. If A plus B has different coefficients, C and D right? So the Kc expression will be C power P D power Q over A power M and B power N. This is the expression, right? So if anyone asks you, write an expression for Haber's process equation. Remember, you can have variety of unit in each case. So this will be equal to Kc NH3 power 2 N2 H2 power 3. So this is the expression. And the unit will be varied accordingly. So this will be mole per dm cube per square. For nitrogen, mole per dm cube, and hydrogen, mole per dm cube ka cube. So this entire thing cancels out this and one of the power from this. So this remains. The unit becomes 1 over mole per dm cube power 2. Right? Let's do one more thing. If you have you are given with this equation, so the Kc expression will be HCl over the units will be mole per dm cube square, mole per dm cube for H2, and mole per dm cube. So everything gets cancelled. So there will be no unit for it. So इसीलिए we can have variety of things happening together. ठीक है बेटा? So if this is asked by the examiner, write a Kc expression for following equation. So it will be पहले तो equation देखो. This is the equation for ester formation. So what will be its Kc expression and what will be its units? Answer me quickly. And please respond whether this thing is clear or not. Send me your answer on WhatsApp. All right, but I'm waiting. Okay, I got your answer. Shabash. And what would be the unit for that? Case expression. Okay, so this is the expression for Kc. And for unit, see if there is any balancing integer. No, 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 no from the equation. So it will be mole per dm cube, mole per dm cube, mole per dm cube, and mole per dm cube. So there wouldn't be any unit for it. So you can write no unit for this. But it's not that difficult to analyze about the units. Just you need to keep in your mind what balancing integers are there. If you are applying the correct balancing integers, then it is fine. So give it up. So one more for testing it. Mm, and it will be NH3, so 4 moles of this, and 5 moles of this, and 4 moles of this, and 6 moles of that. Gas and gas and gas and gas. So make an expression for this. Shabash beta. Quickly completed. So this will be Kc. Shabash. NO power 4 H2O power 6 NH3 power 4 O2 power 5. So if you do the units, mole per dm cube times 4 mole per dm cube times 6 mole per dm cube times 4 and mole per dm cube times 5. So this completely, and this cancels this. The unit will be mole per dm. So in today's session, we have learned how to make an expression. Tomorrow we'll be doing some mathematical problems regarding this. Shabash, madam. Right, so keep practicing. We'll see you tomorrow. I'll upload this class on YouTube so you can see it from there as well to make more and more examples. All right, beta?